Okay, let's just dive right into this. I want you to picture this scenario. You're sitting in the exam hall. The clock is ticking down relentlessly, and you can practically hear every second passing. You turn the page and boom, there it is. The ultimate Cambridge Additional Mathematics Challenge is just staring right back at you. It's a high-mark question. It's demanding you to integrate sums of terms and powers of x. And, of course, it specifically includes those notoriously tricky 1 over x and 1 over ax plus b forms. The pressure in that room is immense. The deadline is looming. And look, for so many students across all the Cambridge syllabus codes, whether we're talking 0580, 0606, 4024, 4037, or even 4040, this exact moment, this specific type of question, it just induces pure panic. The mind goes blank. But in this explainer, we are going to completely break down the story behind the specific question, and we're going to deliver the headline answer that examiners are practically begging to see on your paper. Welcome to the newsroom for your Mathematics Cambridge exam strategy. I am going to show you exactly how to master integration, completely transform your exam approach, and actually turn that intense deadline pressure into your greatest possible asset. So let's get started.
Right off the bat, we have a fascinating quote. A senior Cambridge examiner recently noted that the difference between a B and an A star often comes down to this specific topic: how well you understand integrating sums of terms in powers of x. Let's really look at why that is. Imagine two students tackling the exact same past paper question under that same ticking clock. First, we have Alex. Now, Alex overloads his paper with just raw mathematical facts. He writes down every single integration rule he can remember, cramming them into the margins, but he provides absolutely no analysis or structure. It's literally just a chaotic wall of numbers. On the other side of the room, we have Sam. Now, Sam actually understands the math perfectly well, but under that deadline pressure, Sam rushes. He completely misses the crucial command words in the prompt, he drops his constants of integration, and he completely scrabbles his final presentation. So, what's the result? Both of these approaches result in harsh red pen marks all over their papers. They both lose crucial marks. And here's the kicker, it's not because they don't know what integration is. It's because they lack the proper examiner-aligned strategy to put it on the page.
So, here is our playbook for today's explainer. We'll start with the core principles, then move into the procedural framework, followed by examiner warnings, and finally, critical analysis.
Okay, Section 1. Let's talk about the core principles and what Cambridge actually expects from you.
We really need to look closely at what Cambridge examiners are actually looking for when they're assessing your integration techniques. Look, it is not just about getting the final number right at the bottom of the page. It's an entire assessment of your mathematical thinking process, and this slide brilliantly illustrates the core divide: superficial breadth versus analytical depth. Let me break this down for you. Superficial breadth, that is Alex's approach. It's just memorized facts. It's knowing that x to the power of n integrates to x to the power of n plus 1 divided by n plus 1. And sure, that's great, but it's basic. What happens when n is negative 1? Well, superficial breadth completely crashes and burns right there because the student tries to divide by 0. There's no deeper understanding. Analytical depth, however, is a connected, conceptual understanding. The A-star student knows that integrating 1 over x results in the natural logarithm of the absolute value of x. Furthermore, they can take that concept and transfer it to entirely unfamiliar contexts, knowing seamlessly that integrating 1 over ax plus b gives 1 over a times the natural log of ax plus b. You see, they actually understand the why behind it. They understand the chain rule functioning in reverse. This kind of depth is the absolute hallmark of an A-star student, and it is exactly what the Cambridge syllabus is emphasizing.
So, the absolutely crucial point here is understanding the method mark strategy. This is honestly the secret of the whole exam. The assessment framework prioritizes analytical depth, meaning they award marks for your systematic process and your logical, structured reasoning. You have to prove your methodology step by step. Top students structure their mathematics answers using what we can adapt as the Peel framework: point, evidence, explanation, link. You make your point by identifying the correct integration rule. You provide evidence by clearly substituting your values. You offer an explanation through very clear step-by-step algebraic manipulation. And finally, you link your final integrated function back to the specific context of the question, like, say, finding the actual area under a curve. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving on to Section 2, let's get into the procedural framework and systematic processing.
Examiners absolutely require a standardized sequence so you can systematically process these complex equations perfectly every single time. Yes, even under extreme exam conditions. Let's walk through it together. Step 1. Deconstruct the question. Ask yourself, what are the specific command words here? Is it evaluate? Is it find the exact value? Or is it show that? Those mean very different things. Step 2. Extract relevant data. Are there limits of integration you need to worry about? What exactly are the coefficients? Step 3. Select the analytical framework. Are you dealing with a standard power rule situation, or do you need the natural log rule for that tricky 1/ax plus b term? Step 4. Execute with clear notation. This is where so many students fail. Your integral signs, your dx, and your brackets absolutely must be flawless. And finally, Step 5. Present with correct terminology. Please, whatever you do not forget your constant of integration, that plus c, if it's an indefinite integral. If we apply this rigorous sequence to Alex and Sam, we literally see their red pen marks transforming into green check marks. Think about it. When Sam slows down to extract data and execute with proper notation, he stops dropping his C. When Alex stops brain-dumping random rules and actually selects the specific analytical framework, his work goes from chaotic to legible and logical.
Now, we all know that under deadline pressure, panic is your absolute worst enemy. Your brain just freezes. So here's a fantastic memory hack for you, DSEP. DESEP. Deconstruct, extract, select, execute, present. Write this acronym at the top of your rough paper the very second the exam begins. When you turn to a complex integration question involving nasty fractions and weird powers, just take a breath, look at DSEP, and let the procedural framework guide your pen. It acts as an anchor to keep you grounded and ensures you demonstrate that analytical depth the examiners are looking for.
You might be wondering, why do we obsess so much over DSEP? Because using this exact framework transforms messy, error-prone working into a 100% method mark success rate. That's right, 100%. Even if you make a tiny, silly arithmetic error at the very end of the problem, following DSEP ensures you capture every single available process mark along the way. That is the true mathematics success blueprint. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's jump into Section 3. Examiner warnings. These are the red alerts straight from the source.
So, we've looked at what you should do, but now we really need to reveal the exact traps laid out in the Cambridge Principal Examiner reports. These are the giant red flags that examiners see year after year, paper after paper. Here are the top 3 mistakes students make with integration. First, confusing cause and effect. Under pressure, students frequently confuse the rules of integration with differentiation. Because they're inverse operations, the brain just kind of flips them. They might multiply by the derivative of the inside function instead of dividing by it when integrating that 1/ax plus b. And let me tell you, this immediately derails the entire solution. Second, forgetting format and presentation. This means messy brackets, dropping the dx from the end of the integral, or forgetting that integrating 1/x strictly requires absolute value signs inside the natural log. Details matter. And third, the classic mistake, providing generic answers that are not specific to the context given. Let's say you are calculating an area and you end up with a negative result. A generic answer just leaves it negative and moves on. An A-star analytical answer evaluates the context, realizes that physical area must be positive, and clearly explains that the integral is simply representing an area below the x-axis. Failing to link your mathematical points to the given scenario costs you crucial evaluative marks.
Let's do a quick 60-second visual scan challenge, comparing the flawed approach to the A-star strategy, right here on the screen. Imagine looking at a complex data source or a dense mathematical paragraph in an actual exam. The flawed side skips major algebraic steps. It offers a totally generic answer, and it rushes the conclusion, exactly like our student Sam from earlier. The examiner commentary on papers like this is just brutal. They write things like, "Candidate jumps to the final line without establishing the intermediate integral, losing all subsequent method marks." Ouch. To execute the A-star strategy, you must have incredibly clear working. If you are integrating 3 over the quantity 2x minus 5, your very next line must explicitly show 3/2 times the natural log of the absolute value of 2x minus 5. You have to verify your results. You have to show the examiner exactly how your brain got from the problem to the solution. No magic jumps allowed.
Finally, we reach Section 4, Critical Analysis and Evaluative Thinking.
This is the territory where you really separate yourself from the pack by demonstrating higher-order evaluative thinking.
It is not just about doing the calculation like a robot. It's about evaluating the entire mathematical landscape of the problem. Top-scoring candidates don't just calculate, they perform comparative analysis. The syllabus framework itself comprises descriptive, analytical, and evaluative levels. So to hit that top evaluative level, you must follow these 3 steps. 1. Question your assumptions. Did you just assume the curve doesn't cross the x-axis between your limits of integration? Because if it does, and you didn't check, your area calculation is wrong. You need to check that. 2. Consider different perspectives. Is it actually faster to expand the brackets before integrating, or should you use a specific rule? Take a second to evaluate the best path. 3. Justify your decisions with evidence. When you make the choice to split an integral into 2 distinct parts, you need to write down exactly why, using the roots you calculated as your hard evidence.
This brings us perfectly to the difference between just identifying similarities versus actually drawing conclusions. Real comparative analysis requires way more than just noticing things. It requires using comparative connectives and supporting each comparison with hard mathematical evidence to determine relative importance. For example, if you evaluate the definite integral of a velocity time graph, you don't just state the final number and walk away. You draw the conclusion. You write, therefore, the total displacement is x meters. You actively link the purely theoretical math back to the physical reality of the problem. That is the critical analysis that Cambridge examiners reward with the highest possible grade boundaries. Let's do a quick 30-second speed writing challenge in your head right now. Imagine you just integrated an acceleration function, okay? Your point is the integral rule itself. Your evidence is the substituted limits. Your explanation is calculating the final velocity value, and your link is the conclusive sentence stating the object's final state. That Peel paragraph, applied to mathematics, it is absolutely unstoppable.
Let's recap the complete integration answering system that practically guarantees those top marks. Your cheat sheet for success relies on 3 absolute non-negotiable rules. Rule 1, command word decoding and connected conceptual understanding. You have to know what the question is truly asking and how the rules of powers of x and natural logs apply dynamically to that specific problem. Rule 2, PEL framework application integrated with your DSEP procedural sequence. Deconstruct, extract, select, execute, and present perfectly, every single time. Rule 3, strict adherence to the method mark strategy and your time management matrix. Never ever skip steps, even if you are in a massive rush. Prove your method on the page. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acexams_IGCS and click that bell. Don't let another exam pass you by.
So, I want to leave you with this final provocative thought as we wrap up. How will you apply the method mark strategy to your next past paper? Will you be an Alex, just dumping raw facts and hoping for the best? Will you be a Sam, rushing the deadline and losing silly marks? Or will you be the A-star strategist who systematically controls the paper and gets every method mark available? Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.